Right, now what's happening with PowerPoint tonight on our computers, and it's not just mine, it's Rod's as well, it's not treating PowerPoint properly. So I'm having to do it with the view where you can see the slides down the side. If I do the slideshow from beginning, it doesn't work tonight. So it's an app thing, it's not the computers. Anyway, recent things in space, various missions going on. Well, on the way is this thing. Here are two space crews, one's Chinese and the other one is American, and they have something in common, and that's the fact they are mixed genders. So the Chinese have sent up a crew, which I think is going to be up for 6 months or so, includes a woman. It's her second flight. I think it's also not the first flight for the other two. The Chinese seem very keen on mixed gender flights. I think that's their future model, always. The Americans, well, this flight here it's one female. Sometimes it's 2 out of 4. It's quite a lot. But if I was to show you the average Russian crew, it would be 3 men. Now, that might be a surprise to you, but here are some numbers. Whoops, let's do this. Now, these numbers may be a bit out of date, but as of March, 50 American women had gone up in space. There you can see that. 50 American women were up in space, and the Americans had also launched 10 women from other nations, mostly Europe. But the Russians, only 5 Russian women have been launched by the Russians up until March, and that's still the case now, although I think one's due up on the next flight to the space station in Russia, I think. So there's a huge imbalance. The Russians are not keen on sending women into space. And if you go back to 1963, the Russians launched the first woman into space, Valentina Tereshkova, got the name right. And she was up for 3 days and then came back. At the time, the Americans hadn't even launched anyone for that length of time at all. The Russians did it simply to get a woman in space and to claim the propaganda for it. Once they realized the Americans just were not interested and weren't going to be taking the bait, the female program, cosmonaut training program, was wound up in about 68, 69, and didn't really start up again until the late 70s. Now, after the flight, if you try to find out, how did it go, the sort of thing you would hear was this statement here, for example. This is from a Russian scientist. And there were all these negative reports about it, that she wasn't very good, that she was hysterical in space, that she was sick, she vomited, all this sort of thing. Now, these kind of reports don't come out in the Soviet system unless they are essentially officially sanctioned. So, if you like, the official line, or official in inverted commas, is that she didn't really do very well. And this subsequently turns out to be a lot of old bollocks, because actually she did extremely well. She probably saved the flight because the instructions she'd been given and the programming in the computer were completely wrong. She manually took over and essentially saved the flight and did very well. And she was asked at one point more recently, well, why did you keep quiet about that? And she simply said, well, I didn't want to get the ground controllers who'd made the mistakes. I didn't want to get them into trouble. Well, it's very noble, but the Russians walked all over her. Now this, it's almost misogynistic. That'll come back in a minute. All right, so just bear that in mind. Anyway, moving on. I was asked, or it was suggested to me, I say something about the James Webb telescope. It's about to go up. So here it is being assembled some time ago now, give you some idea of the size. And of course it is a monster. And here it is packed up, ready to go, and it's going to unfurl and become this sort of thing with a sunshade and a telescope bit here. And the sun is always going to be kept on the other side over here, so the telescope is always in the shade. Now, when the telescope was planned back in 20, actually more like 30 years ago, the big thing in astrophysics and astronomy was the early universe, the origin of the universe, the early behavior. Now, that means that most of the light from that period is stretched into the infrared because of the all the red shifting. So the James Webb here is optimized, as you can see in this picture, really into the near infrared and not so much in the optical. So whereas the Hubble at the top here can deal with all the optical and nice bit of UV and then very near infrared, James Webb has sort of moved up across here, and the Spitzer, which I don't think is operating now, was actually another step on because it had more active cooling. So there it is, the James Webb is optimized for that. However, in the last 20 years or so, I would say, actually, I'm not so interested in the early universe. I'd rather know about all these exoplanets, all this sort of thing. I think many people probably agree, that is the big question in astronomy. If there's a competition between what's the most interesting thing, I think it's this. Now, all the information you're going to get about exoplanets, well, whether it's this sort of thing where starlight is occulted, or even if you do, go down here, or even if you do direct observations, what you're looking at in one way or the other is starlight, either reflected or blocked. And you'd think, well, to do that, to see that as best you could, you want to use all the visible light. But the James Webb isn't optimized for visible light. Now, you know, it will deliver something, but it's not what it might have been. But then, of course, it was planned so long ago that the goalposts have rather moved since then. Now, the James Webb is too big to fail. Nothing negative will be reported about it. So don't expect to be told what it can't do. Anyway, it's due to launch on, well, it was the 18th of December. Now it's the 22nd because there seems to be something gone wrong with a fairing or a bracket or something on the assembly up here. But anyway, I don't know how serious that is. And it will launch out, and it's going to be sent out straight out to this Lagrange point, L2. Now, I was asked how it got there. Well, essentially, it will go on it'll be sent on a very, very long orbit, which loops out, and then the orbit's going to fall into this halo, which I'll show you in a minute, and it'll become trapped. And it will take about a month or so to get there. There's no hurry. But we'll just, let's take this on. So it goes out along this path. This is actually the arc of an orbit until it falls into this area here where other effects take over. And you can see it slows down as it reaches out there, which is what you expect on these kind of orbits. So 2 days or so, 3 days, 5 days, 40, and then it slows down. It takes more than a week to do this little bit here. And then eventually it settles down over here. So on the way out, various things open up, get tested. You've got to keep the shade in the right place, so that's pretty important. Don't want anything to warm up, because once you do let something warm up, even if it's by accident, you've then got to let it cool down again. And that means you just got to wait, because there isn't any active cooling. Now, where is it going here? Well, this is the Lagrange points, if you like, looked from above, as a sort of gravitational potential surface. So where the gravity, the Earth and the Sun balances, are these points here, L1 and L2, and also L4 and 5. And actually, if you think of this as like a rubber sheet effect with a big hole in the middle and then smaller holes around here, L1 and L2, although they are where Earth and solar gravity is balanced, they're quasi-stable. They're metastable, in fact. So if you sit at L1, L2, yeah, you'll stay put, but the slightest nudge and any perturbations, and you'll roll down one way or the other. So you have to do something about that, and you have to expend fuel. Generally, you need a bit of fuel just to keep yourselves in the correct place. Now, the James Webb has enough fuel on board for 5 years, and they think they might get to eke it out to 10 years. And then that's it. It isn't a case of, oh, it won't be at a point. It won't be able to hold itself at the Lagrange point. It'll be done. So whereas the Hubble's been around for 30 years, James Webb won't be. 10 years at best. There's no chance of anyone going out there to top it up. So beware. Where are we? At the Lagrange point, if you do look them up on the web, there is a slight confusion around because there's two sets. There's the Earth-Moon system, where you think about the Earth and Moon gravity's balancing, and the Earth-Sun, which is different. So you have to, because this is the Earth-Moon system, and you can talk about sitting things around it, but this is not what the James Webb's going to do. So there we go. It'll be, I'll say the James Webb won't, everyone's got their fingers crossed, it's going to be a pretty tense time, but in a sense, it just can't fail. It's too big. And no matter what it does, it's going to be portrayed as a success. Politically, it has to be. Anyway, let's go on. This is the Curiosity rover, not Perseverance, the more recent one, but Curiosity that's been there since 2012, 2013, quite a while now. Now, you might think this is a successful rover and it trundles around, delivering all sorts of science. Isn't that marvelous? Well, actually, no, it doesn't. For the first thing which has been appearing in the literature is where it was actually sent in this Gale crater, which was meant to be on the left here, at one time, a nice lake. That was the idea. And therefore, if you looked around, you would find standing water. It had plenty of time to work on the soils, and life could have got a hold and so on. But it turns out when you look at it more closely, as they now do, that actually, no. If anything, there were a few puddles there. Not that level. Altitudes are not quite what they thought. And also looking up close at the various layering that they can see, it's wind, it's wind driven. So you then wonder, well, how on earth did they put it in, how on Mars did they put it on a place that was not standing water for a very long time like they thought it was? Essentially, it's not been sent to the right place. It's never going to find what they originally thought because, well, most likely there were only ever puddles there, ephemeral, as they say. So that raises a question mark about what it can deliver. But beyond that, there's other problems. Very quickly after it arrived, there were problems with the tires, the wheels here. They simply are not up to it. The plate here is developing holes, and this realized they weren't strong enough to go over various little stones and things. And since this became a problem, they have to be really careful where they send it. They cannot send it over rough ground. It's got to stay on smooth ground. It must avoid anything that looks like a rock. And that really has complicated things. It's a design problem. Now, the Perseverance has got much stronger wheels. They learned. But you don't hear much about that. And there's more. Now, in the background, there has been very harsh criticism of the Curiosity probe mission. I know I couldn't find it. There was a lot of criticism of the actual instruments they took. They're very, very conservative in what they think, what they can do. So if the Americans think they're looking for life, well, Curiosity, to some extent Perseverance as well, could be confronted by a living thing and not recognize it. They haven't got the instruments for it. Whereas even the Beagle, remember the Beagle 2 that didn't quite work? Well, that really would have found something had it been there. Well, Curiosity and Perseverance won't. There's also criticism about what is it actually doing? And it seems to trundle around. And they say there's criticism that it's trundling around without actually doing anything. And when it is set things to do, they're awfully conservative. And when they look at in terms of delivery per dollar, if you like, spent on it, Curiosity comes in very, very low. I think I've listed 10, it was 10th. So this should be a top 10 thing here. There has been a lot of quiet criticism that undoubtedly you've not been aware of. And well, why not? Well, again, Curiosity is too big to fail. Now, there are those in the planetary exploration community who think that Mars gets too much money, that it's too easy, that, okay, we're incrementally learning things. But if you were to send a mission the equivalent of, say, half a Curiosity to somewhere like Titan, you'd find out a darn sight more that was new than you're going to find out with 3 or 4 Curiosities. But Mars is relatively easy to get to. So the arguments are quite bitter. By no means settled. But overall, there is this thing NASA cannot admit to big mistakes, or it can, but only in sort of obliquely. So there you go. Perseverance has learned, well, the design of Perseverance and the mission itself benefited a lot from Curiosity, more so than I think is generally publicized. Right, moving on to the ISS, which is in the news for all sorts of reasons at the moment. Now here is the space station. Now it's essentially the modules where everybody lives is across the middle here, and the American modules are at its left-hand end, and that's actually the direction this thing is traveling in. So this is the front, if you like. So the American modules are here, and the Russian ones are here in the darker bit, and here they are sort of flipped over and put the other way. This is the Russian modules. The Soyuzes can dock there and progress cargo things, although they are more or less the same as Soyuz probes, really. Now, here, this module here, which I don't want to pronounce, begins with a Z. There have been a few problems with that. It's quite old, and it was noticed, here we go, some time ago. Here, this is again the two segments of the living quarters. This module here, they noticed that the walls were getting cracked, that the module was aging. Now, most likely it's quite old, and then there's the question of, well, how well was it built? And the Russians, although you think they throw money around as a superpower, their economy is about the size of that of Italy. They do not have the funds to build things as thoroughly and test them as thoroughly as they'd like to let you think. Anyway, going on. So here's a report. This is from last year, I think. Is it last year? Maybe the year before. Where they discovered there were cracks in the walls, and it was saying by some Russian officials, this is going to get worse. And you can't really repair these things. Really, you can't just stick glue over them. They're systematic of what's happening to that module, and by implication, the other Russian parts. And they're aging. They're past their sell-by date, as it were. Now, this is what some officials have said, but there are other officials who come out and just deny the whole thing. Oh, no, rubbish. There aren't any cracks. Well, which is it? Well, you'll see that it's not as simple as that. Nothing with the Russians ever is. And moving on to this year, back in this August, I think it was, they delivered this new module, the Norka, if I pronounced it properly. This thing here, which was slotted on here. So here we're looking at the ISS from below, which is the way we'd see it. There's the American bit, there's the Russian bit, and in the port facing downwards is this new docking module. And because it's facing directly down, I think when the space station passes over, it's not easy to see in images, but I've not really had the chance to find it out yet. Now, the delivery of Norca was very difficult. When it was launched, there were problems with the rocket going up, the fuel, I think an engine cut out too soon. They had a lot of trouble getting it up into orbit. When they did, it didn't seem to have the fuel that they really expected. So there's a lot of problems with that. And once they docked it with the space station, well, it seemed to go all right. And then suddenly the space station was tumbling all over the place because the thrusters, the little maneuvering thrusters on the Norca were firing in an uncontrolled way. Now, the initial reports were, well, the station swung around a bit, but it was soon recovered. But it began to come out, and amateurs as well doing radio tracking and so on said no, the space station swung around a hell of a lot, and it was one of the most scary things that ever happened to it. Now, as soon as it starts to swivel around, the solar cells are not pointing at the sun properly. You lose power. Now, although there are batteries, yeah, you can wish it uses it every time it goes into the dark. It's not a good thing. Scary. So this was very frightening, but of course initially it was all, you know, watered down. But anyway, here we go. Eventually, after a little while, it was admitted that, well, actually it did spin around quite a lot, and it was all down to the Russians. They had to bolt with their thrusters, with their software, goodness knows what. But then, what do you think? What do you suppose the Russians did? Well, within about a week or so, this story here on the middle of the page downwards was released, and the Russians were claiming, and something that had happened 3 years before, that they had found a hole in the wall of one of their modules. Here it is, nice little hole, and they claimed that an American astronaut, a female astronaut, had done it with a screwdriver or something when she was having a breakdown, and she wanted to return to Earth early, so she damaged the space station. And this was an official Russian spokesman in Moscow. This isn't just some made up, like the equivalent in the Sun or Daily Mirror. This is an official accusation. Now, the Americans, or NASA, says immediately, well, it's complete crap. We know where our astronauts are all the time. None of them were ever in that part anyway. They declined to release the medical records of the astronauts, which you can kind of understand. I mean, it's a bit medical confidentiality and so forth. You don't need to blurt out these things. But my suspicion is that actually this lady did have some sort of problem. It may have just been a headache. It might have been she had a bad tooth. It might be anything. But the Russians got wind of it and put it in their back pockets and then play it out in a distorted way when it suits them. And they need to play a card then because they'd essentially been humiliated the week before. Now, you wonder, would they have done that had this astronaut been male? And in fact, why did they choose a female to target? Because it's absolute nonsense. You know, it is absurd. Well, go back to how they are with the female cosmonauts. They're not keen on them. So that's where we started. I can't help but think that it leaves a very nasty taste, this. The Americans just have to put up with it for now, but it won't be like this for too much longer. The Russians have announced, or let it be known, that they want to get out of the space station. This is why the business with the cracks is not straightforward. That could be very convenient, a reason for getting out. On the other hand, it's embarrassing for Russian engineering if the spacecraft isn't as good as they say it is. Which way do they want to go? Well, it depends who's calling the shots at the time. Now, the Russians are launching another docking module to the ISS, I think today. Maybe even it's gone up today, I don't know. So they're still investing in it, but there is this strange, the Russian space program, and that isn't led by one voice. So depending on how the political winds are blowing, you hear different things. So yes, they would like to apparently set up their own, especially if they're getting fed up with the American sanctions and so forth. Well, that's political. And with what may be going on in Ukraine before too long, it's going to get a lot worse. So watch this space, as they say. Furthermore, the Russians have even said they'll leave it and they'll build their own. And these are the quotes from the Russians again. I mean, they are just ridiculous. They're talking here about the fact they'd like to go on a different orbit so there'll be lower radiation. Well, that is just nonsense. The space station on the ISS goes on a high inclination orbit at the moment to suit the Russians. The Americans would, for their own accord, go at a lot lower inclination. It's just absurd. And the Russians and Chinese are going to build themselves a lunar space station. It would be automated, but it's the politics of it. So if you're confused, well, so you should be. If you get a taste for that sort of thing, recently, just a few weeks ago, the astronaut Chris Hadfield published this novel, and I've had the audio version. And generally, novels by celebrities tend to be pretty awful, but this one is jolly good. I mean, afterwards you wonder, that was a bit unlikely, that was a bit unlikely. But if you just want a jolly romp, I absolutely recommend it. Look at the reviews on Amazon and go for it. And while we're on that flavor, if you like that sort of thing, you've got Apple TV, and if you buy an iPad or something, I think you get a few months free. It was a year actually for a while. This is an alternate history thing. And the Americans and Russians are fighting it out on the moon in the 1980s. It's superb. And it's all reasonably believable, except for the history. Now, as of the other day, the Russians blew up a satellite, you might have heard, for a test. Why did they do this? Well, it demonstrated that they could do it. They just shot one down, but the orbit of it intersects with the ISS. There's a slight difference in altitude, but it's only about 20 miles. So the ISS was in danger, and every time it crosses this path, there's all sorts of precautions have to be taken in. Now, the Russians deny that it was dangerous. No, everything's perfectly safe, and they prove they can do it. Although as time goes by, the orbital debris, this is a Chinese test from a few years ago, spreads out all over the place. What are the Russians playing at? Oh, God knows. I mean, they're investing in the ISS. Why do they want to blow it up? Well, it's the military and the Roscosmos, the Russian equivalent of NASA, are not the same thing by any means. And when it comes to decisions, the military will win out all the time. So if that ever clears up, I don't know. But if it makes you scratch your head, it makes many people do that. And then just finally, I think I better rush this. The DART, which went off last night, there it goes. It's going to hit an asteroid. It's going to hit this little satellite asteroid, which isn't a very big one. There it is. That's the satellite asteroid. There's the parent, and there's the DART invisibly there. The original flight plan was that it would spiral out with an ion engine and eventually get there like this, but actually SpaceX won the contract to launch it and gave it a big rocket, and they're sending it there directly, so this isn't being used at all. And the SpaceX sent it up, put it in a parking orbit, and then fired it off on this trajectory straight away. There is a ion engine which will be used. It's a new format, so it's got to be tested. The solar panels are a new type. They've got to be tested in deep space. The main antenna is a new kind. The navigation system is new. There's an awful lot of engineering going on, but ultimately it's going to fly into this little thing here. 10 days before it gets there, a little small satellite is released to follow it, and that'll film the collision. And this is going to be like throwing a fridge at something the size of the Ellen Road Stadium, I think, something like that. But because it's in orbit around here, if any change at all, even just a fraction of a percent, will show up in the orbit. So I think it takes about 12 hours to go around the asteroid. That might change by 10 minutes, 5 minutes, something like that. But you'll be able to measure it, which you couldn't do with any accuracy, with enough accuracy, if it was just free flying. So that's going to be at the end of September. After that, at some point in the future, a European probe will arrive and have a look at the damage, sort of aftermath. And there we go. That's space news. So I better unshare, I think. There we go. There we are.
It doesn't bode well for global relations in space, does it?
That's excellent, John. Thank you very much.
Yeah.
Well, hang on,
One interesting thing, talking about the James Webb Telescope, in Physics World, which is the Institute of Physics magazine, there's been some articles recently, and some people want to change the name of the James Webb Telescope, because I think Webb obviously said something which in these curious days is regarded as not a good idea, to do with race, I imagine. So it may then end up being called something else in due course. So there's a bit of useless information.
No, I'm not. In some ways,
A lot of interference.
yes, there is.
So it's to do with LBGT rights or something that
It's that sort of thing, yes.
Yeah.
I'm just saying, John, it doesn't bode well for amicable relations in space beyond this atmosphere, does it? Really, all this foolish politicking and one-upmanship, you know.
No.
It's quite depressing, really.
Well, if you work with the Russians, you've got to have low expectations, because ultimately they'll let you down. I mean, that's a personal view of mine, but
I agree. Yeah.
I mean, I'm sorry about the feedback on this. If you read Chris Hadfield's book, which I do recommend, at the end of it, you think, oh my gosh, the Russians are terrible, aren't they? They did this, and this. And you think, oh, it's just stereotypes. And then you hear about the satellite test and you just think, there you go. But I think the episode with the NASA astronaut and the accusation that she stuck a screwdriver through the walls of the space station, that epitomized, that is it in a nutshell. It's a very Russian thing to do, an accusation like that, especially if there is even the slightest bit of a medical problem with her. And my suspicion is there is, and they know about it, although it's nothing like what they're saying. And they've done it to a woman, which I don't think is a random act of violence, as it were. So yes, there we go. Yeah.
Could you just explain, John, what is inferior about the James Webb Telescope's frequency window compared with the previous vehicles in regard to sensing exoplanets? Why are they less detectable in the?
Well, it's not that they're less detectable. It's that most of the data in starlight is going to be in the visible range. Stars are not that active in infrared. I mean, they are slightly active, but not as much as they are in the visible and near UV. And you've thrown away half the visible spectrum because you can't see it. Now, in a sense, the James Webb can afford to do that. But if you were designing a telescope to look for exoplanets and you put in the budget of the James Webb Telescope, it would have different capabilities. The James Webb was designed so long ago that, tastes have changed, I think. But again, it's too big to fail, and it can't really be admitted to. Politically, it can't. They're not going to say, oh, James Webb is going to do this, but it couldn't do that. No one in NASA is going to say that at all. But like everybody else, I can't wait to see what it'll do. Yeah.
I get the impression that there is a quite a big interest in what happened in the extremely early universe just after the Big Bang. So maybe, I mean, you know, this telescope will be very useful for looking at the extremely early universe after the start of the Big Bang.
No,
So, you know, it's not all, you know, it's not all doom and gloom about it.
oh no,
surely.
no, not at all. If I wanted to, if I had a choice between knowing about the early seconds of the universe and all about exoplanets, I'd choose exoplanets. But that's my personal taste. And I sometimes think the physics of it, if you take, say, the LHC, of the discovery of the boson, that changed everything, didn't it? Well, no, not really. And yet, what did it cost? So,
I do agree that exoplanets are very much flavour of the month, you know. And I mean, I'm particularly interested in exoplanets, but as Andy says, I mean, I can't foresee a time when exploration of the earliest possible moments of the universe will ever be kind of not popular or won't have any sort of passion to it. But they're two different things, aren't they?
yeah, they are. But when you get to funding bodies and things, you will see over the next few years that there will be things that are more favoured than others. It won't filter through for a year or two, maybe longer.
Sure. Yeah.
I mean, for example, if you're going to have to apply for time on James Webb, who are they going to give it to?
Yeah.